Hello everyone, welcome back to Vienna classes. So we will continue with the exercise 10.2, but before starting, one request, don't forget to like, share and subscribe the channel and the videos. Now here question number 7, it says the medians AD, BE and CF in a triangle ABC pass through point G. So the three medians AD, BE and CF of the triangle ABC, they pass through point G. So the point where the medians pass through, that is known as the centroid. So here now, if GF is equal to 4 centimeter, if you are given that GF, this part is 4 centimeter, then you have to find the value of GC. So solution for the first part. Now we know that CG ratio GF is 2:1 because the centroid divides the median in the ratio 2:1 because centroid divides the median in 2:1. So if this is there, so you have CG upon GF as 2/1. Now here we are given GF as 4 and we need to find GC, that is CG. So CG upon GF is 4, so CG upon 4 equals to 2/1 and cross multiplying it, you get CG as 8 centimeter. So this is the first part. Now in the second part, you are given AD, the length of the complete median AD, which is 7.5 centimeter, and you have to find the length or the value of GD. So here in B part, again AG upon GD is 2:1. Again it is 2/1. Now here what is given to us? We are given the value of AD and we need to find out GD. So GD, it is okay, it is an unknown value, we need to find out, but we even don't know AG. This is also unknown to us. So what we will do is, we will rewrite it as AD minus GD. AG will be written as AD minus GD upon GD, which is equal to 2/1. Now substitute the values wherever it is possible, or still if you want you can simplify it first. So you have AD minus GD is equal to twice GD. So AD equals to twice GD plus GD, that is AD is equal to thrice GD, and if AD is thrice GD, then GD is AD upon 3. Now what is AD? AD is given to us as 7.5. So GD is 7.5 upon 3. So 7.5 divided by 3 gives you 2.5. So this is the length of GD. Now let us move towards question number 8. Now question number 8, it says triangle ABC is an isosceles triangle in which AB is equal to AC. We have here that in this triangle ABC, it is an isosceles triangle where AB and AC, they are equal. D is the midpoint of BC. Now you are also given that D, this point is the midpoint of BC. Prove that circumcenter, incenter, orthocenter and centroid all lies on the line AD. Now what we have to prove? We have to prove that circumcenter, it lies on AD. We have to prove that incenter, it also lies on AD. Orthocenter also lies on AD and centroid also lies on AD. So what is circumcenter first? Circumcenter is the point where all the perpendicular bisectors of each side meet. So we need to prove that AD is the perpendicular bisector of BC. If we prove that AD is the perpendicular bisector of BC, then it means the circumcenter will lie on AD. Similarly, in center, it is that point where all the angle bisectors of the triangle meet. So here, if we want to prove that in center lies on AD, then we need to prove that AD is the bisector of angle A. Third, orthocenter. Now this is that point where all the three altitudes of the triangle meet. So again, to prove that orthocenter lies on AD, we need to prove that AD is the altitude of triangle ABC. And the last one, that is centroid. Here, this is the point where all the medians meet. So we need to prove that AD is the median. Then AD, the centroid will lie on the line segment AD. So we'll try to prove it one by one. So at first, let us go with circumcenter. So here, we will first prove for the circumcenter. Now for circumcenter, what we need to prove? We need to prove that AD is the perpendicular bisector of BC. So for that, to prove it, let us have the two triangles which are there, that is triangle ADB and triangle ADC. These two triangles which are there. What we will do? We will first prove that these two triangles, they are congruent to each other. So as we are given that AB is equal to AC. It is already given because it is an isosceles triangle. We are also given that BD is equal to DC. That D is the midpoint of BC, this is also given to us, and the third side AD, it is a common side. So AD is common side. Now with these three sides of both the triangles being equal, we can say that triangle ADB is congruent to triangle ADC. This is by SSS congruence rule. Using the SSS congruence rule, we have proved that the triangles are congruent. Now, triangles being congruent, angle ADB will be equal to angle ADC. They are the corresponding parts of congruent triangles. These two angles will be equal. Now, if you see those two angles, ADB plus ADC, the sum is 180 degree because they form the linear pair of angles. They are the linear pair of angles. And we have proved that these two angles are equal also. They are even linear pair, means the sum is 180. Hence, what we get, that angle ADC and angle ADB, they both will be equal to 90 degree. Now this being 90, we prove that AD is the perpendicular on BC. Therefore, AD is perpendicular bisector of BC. Now why it is the perpendicular bisector? First we have proved here that it is making an angle of 90 degree with BC, and we are given that D is the midpoint of BC. So if D is the midpoint, means it is bisecting BC and it is bisecting perpendicularly. Now because AD is the perpendicular bisector of BC, therefore circumcenter of triangle ABC lies on AD. So hence the circumcenter will lie on AD. So first part is proved. Now the second part, it is for incenter. Now for incenter, what should be there? In order to prove that incenter lies on AD, we need to prove that AD is the bisector of angle A. Now here, because triangle ADB is congruent to triangle ADC, we have already proved that these two triangles are congruent. So because the triangles are congruent, therefore these two angles will be equal. They are the corresponding parts of these two triangles, congruent triangles, that is angle BAC is equal to angle CAD. The two angles will be equal, corresponding parts of congruent triangles. Now if these two angles are equal, then it means that AD is bisector of angle A. So here this proves that AD is the bisector of angle A. Now if AD is the bisector of angle A, then it means that incenter of triangle ABC lies on AD. So the incenter of the triangle will also lie on AD. Now we will move towards ortho center and then towards the centroid. So if you check it out, for the ortho center now. Now ortho center, what we need to prove, that AD is the altitude of triangle ABC. Now in A part, we have proved that angle ADB is equal to angle ADC equal to 90 degree. We have proved that these two angles are 90 degree in first part when we proved that this AD is the perpendicular bisector of BC. Now because it is proved that these angles are 90 degree, hence AD is altitude on BC. So what is AD? AD is the altitude on the side BC, and the altitudes, all the three altitudes of the triangle, the point where they meet each other, or the point of concurrency of altitudes, that is known as ortho center. Therefore the ortho center of triangle ABC lies on AD. So this is also proved. Now the last part, it says that we have to prove centroid also lies on AD. Now what is the point centroid? Centroid is the point of concurrency of all the medians. So we need to prove that AD is the median of triangle ABC. Now it is given that D is midpoint of BC, and what is a median? Median is a line segment which joins the vertex to midpoint of the opposite side. and we are already given that D is the midpoint of BC. Therefore, this line segment AD will be the median. Therefore, AD is median on BC, and the point where all the three medians meet each other, that is known as centroid. Hence, centroid of triangle ABC lies on AD. So in this way we can prove that all the ortho center, the circumcenter, the incenter and the centroid, they all lie on the line segment AD. Now let's move towards the next question. Question number 9. Now question number 9 says the ortho center of triangle ABC is H. We are given a triangle ABC where the ortho center is H. It means the altitudes of all the altitudes of this triangle, they meet each other at point H. The midpoints of AH, BH and CH are respectively X, Y and Z. Now if we draw the altitudes AD, BE and CF, they meet at point H. X is given as the midpoint of AH, Y is given as the midpoint of BY and Z is given as the midpoint of CH. We have to prove that ortho center of triangle XYZ. Now if we join these midpoints X, Y and Z, we get a new triangle. And what we have to prove? We have to prove that the ortho center of this triangle is also H. The same point. The ortho center of triangle ABC is the ortho center of triangle XYZ. So given and to prove that you can write it yourself also. Now here AD, BE and CF are altitudes of triangle ABC. We are already given that AD, BE and CF, they are the altitudes of the triangle ABC. Now, in triangle HBC, now take the triangle HBC. If you take this triangle, Y is the midpoint of BH and Z is the midpoint of HC. So Y and Z are midpoints of HB and HC. Therefore, YZ is parallel to BC. The two lines YZ and BC, they will be parallel to each other. Reason being, Y and Z are the midpoints. So line segment joining the midpoints of two sides is parallel to the third side. This is by the midpoint theorem. Now using the midpoint theorem, we prove that YZ is parallel to BC and AD is perpendicular to BC. It is given that AD is the altitude. So AD is perpendicular to BC and YZ is parallel to BC. Therefore, we can say that AD is also perpendicular to YZ. If you see here, this AD will also be perpendicular to YZ. Now this AD, part of it is XP. XP is the part of AD. So we can write here or XP is perpendicular to YZ. Either you say AD is perpendicular to YZ, or we can say XP is perpendicular to YZ. Why is it so? Because XP is part of AD. Now what did we prove? That in this triangle XYZ, this XP is the altitude of on YZ. Now similarly, we can prove that XZ is parallel to AC. BE, it is already perpendicular to AC, so BE will be perpendicular to XZ, and in turn this YQ will also be perpendicular to XZ. So we can say that YQ is perpendicular to XZ, and in the same way ZR will be perpendicular to XY. ZR is perpendicular to XY. Now if we prove this thing, these XP, YQ and ZR, they are parts of the given altitudes, that is AD, BE and CF. Now AD, BE and CF meet at point H. Therefore, XP, YQ and ZR also meet at point H. So these altitudes XP, YQ and ZR, they also meet at point H. And if these are meeting at point H, it means altitudes of triangle XYZ meet at point H. So what does it mean? It means that the altitudes of triangle XYZ, they meet at point H. Hence, H is ortho center of triangle XYZ. So H is again the ortho center of triangle XYZ. So this is it. Now the last question of this exercise, if we go through, it says, how will you find a point on side BC of triangle ABC which is equidistant from sides AB and AC? Now here what it is, we are given a triangle ABC and we need to find a point P where on side BC. We need a point P on the side BC which is equidistant from the sides AB and AC. So we need which is at equal distance from AB and AC. So here don't get confused, it is not equidistant from B and C, but it is at equidistant from AB and AC. Means AB and AC, they are the two intersecting lines and we need a point which lies at equal distance from these two lines. So in the solution here, because they are asking you how will you find, so what we will do is we will draw a triangle ABC. Now after drawing a triangle ABC, take a point, say D. We are taking a point D equidistant from AB and AC. We take a point D which is at equal distance from AB and AC. That is DM is equal to DN and DM is perpendicular to AB. DN is perpendicular to AC. Because when we say that it is equidistant from AB, it means we are talking about the perpendicular distance. So DM and DN, this distance is equal, and DM is perpendicular to AB and DN is also perpendicular to AC. Now, in triangle AMD and triangle AND, if you take these two triangles which are formed here, we have AD, it is the common hypotenuse. AD, it is the common hypotenuse of this triangle. Angle AMD is equal to angle AND. They each are 90 degree, and DM is equal to DN. They are equal. No need to write any reason because we have already done it. So with these three parts, we say that triangle AMD is congruent to triangle AND. This is by Rhs Congruence Rule. Now if these two triangles are congruent, then it means their corresponding parts will be equal. Hence, angle MAD is equal to angle NAD. They are the corresponding parts of congruent triangles. Now you can see here that if these two angles are equal, that is MAD and NAD, if they are equal, then AD is the bisector of angle A. Therefore, AD is bisector of angle A, or you can name it as angle BA, that is AD. Hence, any point on angle bisector AD will be equidistant from AB and AC. It will be equidistant from the two line segments, that is AB and AC. Now, produce AD to intersect BC at point P. So what do we do then? We will produce this AD so that it intersects BC at point P. Therefore, P is the required point on BC. This is the point which was required on BC, equidistant from AB and AC. So hence we get the point which is required, and with this we come to the end of this exercise 10.2 also, and with the end of the chapter. We'll meet again and we'll start a new topic. Till then, all of you have a nice day. Thank you.